Okay, so as I mentioned in the next section, what we're going to do is talk about how to access the equipment that we're going to be using, the routers and the switches, and then also the Windows machine that you can use for testing inside of the rack. Now, what is always going to stay the same throughout the week is what the physical network looks like, what the physical wiring or what the physical topology looks like. And the network is going to be made up of 5 routers, 3 switches, and then this test PC we're going to use for testing some of the applications. Now, in order to connect to the routers and switches, these have what is known as the console port. And the console port is basically an RJ45 interface, just like your NIC card is on your PC or your desktop machine. But it runs, instead of Ethernet or IP, it runs a protocol that is known as RS-232. And RS-232 is a serial protocol that was originally designed for accessing dumb terminals, like Unix machines from a mainframe. So the idea behind this is that we can come in from a direct connection, like we have some sort of management station that connects to the console port of the routers through the serial interface of the PC or whatever this terminal is, connects to the console, and then we can make management changes on the routers. Now, obviously, we don't have the physical routers here in the class, so we're not connecting to these physically. What we are instead doing is coming from the internet, and we are telnetting, and I'll talk about what that means in just a minute, but we're going to be connecting remotely through the telnet protocol to basically a machine that is the access server. And the access server is going to be performing these console connections to the devices on our behalf. So the end result is that when we open up the telnet sessions to the devices like router 1, router 2, etc., it would be the same as if we had a physical cable running from our machine into the console port for the management. Now, in order to do this, we need to run an application that runs this, either this serial protocol if we were directly connected, or in the case of us where we're coming from the internet, we're going to be using the telnet protocol. So we'll talk about it in more detail later once we get into accessing the machines, some of the specifics that we can do with the telnet protocol and other management protocols like SSH that are used to manage both the routers and the switches. But in this case, what we're going to be doing is connecting to the host name, or basically the domain name, where our DNS entry is going to go to rax.ine.com. And this access server at rax.ine.com, it's listening for a telnet connection from us, which telnet is an application that uses TCP as a transport. It uses layer 4 for TCP, and this runs on TCP port 23. So what essentially we need to do is run some application that's going to open up the telnet connection. So this could be as simple as like the Windows or the Linux or Mac OS command line that runs the telnet process, or we could run what's known as a terminal software. So some of the common terminal softwares would be like Hyperterminal, which was one that originally came with Windows. Terminal. Another one that's popular is Secure CRT, which is the one that I'm going to be using this week. And an open source one is PuTTY, or P-U-T-T-Y. So if you don't already have one of these installed, usually PuTTY is the easiest one to get access to because it's open source, it's freeware. And if you just search for PuTTY, P-U-T-T-Y, a free telnet and SSH client. So this is essentially the network application, which is running at layer 7 that we're using. So from here, you can download PuTTY. In this case, I think it's just a standalone exe file. And when you run this, it's basically going to ask you what type of connection protocol do you want to run. So there's a couple different options here. One of them is Telnet, there's SSH, there's also Serial, which we would use if we were physically attached to the console of the router. But in this case, we're going to be running Telnet. So Telnet's the application. The host name that we want to go to is rax.ine.com, and Telnet by default is going to run at port 23. So once you open this connection, you should get a username login box. It's going to ask you for the credentials. Now I'm going to be using Secure CRT, which you'll see the font is a little bit easier to read, but it's basically the same thing as PuTTY. It's just a terminal client that's using either Telnet or SSH as the network application to send basic characters to the routers or to the switches. So from here in Secure CRT, I'm going to make a connection. The protocol is Telnet. The host name is rax.ine.com. So here, this is connecting to our main access server. And it's going to ask me for the login information. So on those sheets of paper that we passed out, that's going to have the password for everyone. And there's going to be 8 different devices that we're logging into. It's going to be the rack name, which the rack name is np rack followed by a number. So if you're on rack 2, it's going to be np rack 2. If you're on rack 3, it's going to be np rack 3. And then followed by the individual device name. So the device names are R1, R2, 3, 4, 5, then SW1 for switch 1, and switch 2 and 3. So these are the 8 devices that we're connecting to their consoles. So if you're assigned to rack 2, you're just going to replace this with a 2. So this is what your logins would look like. All 8 of the sessions are going to be using the same password through the week. So if you have some advanced functionality through your terminal software, one of the things you can normally do is set up a login script, which when it asks you for the prompt, like your username, I could automatically have it send this username and then what the password is. But the ultimate result of it, what you should see is when you log in, so I'm going to log in here as nprack1r1, and then the password that's on that paper. Okay, the password is going to be, it's all lowercase, and it's 2 alpha characters, so 2 letters, 2 numeric, so 2 numbers, and 2 alpha, all in lowercase. So you type the password in, hit enter a couple times, and it should give you some sort of prompt. Now, what it actually returns with is going to depend on what the current state of that device is, what the current state of that individual router or switch is. But regardless, you should be able to then open up multiple connections. So if I go to the quick connect again, and again, I'm telnetting to rax.ind.com. Okay, so rax.ind.com, I should have written that down as well. But this is the domain name that we're connecting to. It's at TCP port 23. And you want to log in with each of these individual logins. So I'll have nprack1r2, and it's going to be the same password. Over and over and over for all of the individual devices. Now, you don't necessarily need to open all of them right now, but we are going to be using all 8 of them throughout the extended class. R3. Now, personally, I have a login script set up that I'm going to be using for myself to make this a little bit easier. And basically what it does is just to open these individual sessions where when it's asking for the username, it's returning that username and the password. And then this is connecting me to the command line of all the devices. Now, there may be some initial configurations that were on there from some previous sessions, but we're going to go through everything from the very first basic step of connecting to the devices, where the first thing we're going to do is delete their previous configurations and erase them and reload it to a complete blank configuration for the devices. Okay, so there's 8 different devices we're connecting to again. The 5 routers and the 3 switches. So this here is showing what the device's physical Ethernet wiring is, or basically the LAN cabling, where the routers are all connected in some sort of manner to these switches, switch 1, switch 2, and switch 3. And then also we have this connection to the test PC. Now for the regular routers and switches, we're coming in from the console because we're connecting in through that access server. Now the access server normally is essentially some device that has lots of console ports. And an example of this would be like a Cisco 2511, where this device has, you can't really see it that great here, but essentially these ports here, these are actually SCSI 2 ports, where you plug these serial cables in, and then on the other side it has a normal RJ45 connector, where this is called an octal cable. So if you look at the octal cable, basically the result of the other end is that these are just normal RJ45 ports. So it looks like an Ethernet port, but it doesn't run Ethernet. It runs this RS-232 serial connection. And actually, let me find a better picture of it. It would look like this. Okay, so it looks like this, where essentially we have a router that has tons of these SCSI ports, and then on the other side, these are the RJ45 ports. These go into the consoles of the routers. So the key is that even though we're remotely accessing the devices, it looks like we're directly connected to them. So even if they don't have any configuration, we can still send them commands, because this console port is known as the out-of-band management, or OOB for out of band, which essentially means that even if the network is not configured, like we don't have any IP addresses on the router's interfaces, we can still connect to this port because we have some sort of other network that is outside of this that's built just for the management of the devices. So in a lot of network designs, you'll see that you build your normal network for your regular data traffic, like for reaching your web servers, your database servers, whatever. But then to manage those devices, unless you want to be physically plugged into them every time you want to get to the router, you need some sort of out-of-band management technique. And that's what these routers are designed to do. That they're normal Cisco routers, normal layer 3 IP routers, but instead of using Ethernet or using serial, they're using these RS-232 ports to get to the devices. Now for the Windows machine, we want to get to the GUI interface. We want to make it look like we're directly connected to that. So here we're not using a console connection. We're going to be using the Windows Remote Desktop Protocol, or basically the regular screen sharing for Windows. So most likely everybody probably already has the remote desktop client built in. And the key here is I just want to make sure that everyone is connecting to the right number. Otherwise, you would be connecting to someone else's rack instead of yours. So we're going to go to, and again, I'm going to print this out for everyone as a reference later, so you don't need to remember all of this. But the URL is going to be np. It is npvpn.ini.com. And the remote desktop port, normally remote desktop runs over TCP, and it uses port number 3389 normally. But since we have multiple sessions going to the machines, I have it configured to listen to different port numbers depending on the device that you're going to. So for rack 1, the port number is 60,001. Rack 2 is 60,002. So just whatever rack number you are, if you're rack 3, your port number is going to be 60,003. So just whatever it's 60,000 plus your rack number. So if you open up your remote desktop, so remote desktop connection, and I'm going to go to, again, npvpn.ine.com, then the port number. So in this case, 60,001, because I'm on rack 1. And I may need to double check this config on our next break. npvpn.ine.com. Okay, so I'll double check this in a minute, but eventually everyone is going to end up on the remote desktop of the Windows machine, and then essentially you'll be inside of this network. So any changes that you make, you'll be able to talk to whatever the devices that you set up for routing. Now normally when a device is routing IP, which let's look at that diagram again. Okay, this Windows machine, this has 2 network cards. It has one that is going to inside of our test rack, and then one that is going out to the internet. Now normally in order for this PC, who is running IP version 4, in order for it to reach us on the internet, what does it need to know about this connection? Or what does it need to know about this direction? Okay, if you were to go to your Windows machine's command line and say ipconfig, what are some of the key points about those options that you would see?
The IP and the subnet mask.
Okay, one thing is that it has an IP address. It's also going to have a subnet mask, which is going to tell it who's on my network directly and who's on a different network. And it says for anyone who's not on my network, then I'm going to send my traffic where? To the default gateway. So normally the default gateway is going to point this way to the internet, but I'm using kind of a trick here with addressing that we're going to talk about later in the week that has to do with network address translation, or NAT. But we'll see that from this PC's perspective, our machines are going to look like they're directly connected. So it means that the default gateway doesn't need to point this way. What this is going to allow you to do is on the PC, you can point your default gateway into the rack. So once we actually go through the configuration and go through different routing setups and different layer 2 switching setups, we can use this test PC then for like telnet testing, for TFTP, for changing iOS images, for web browsing, any applications that we want. We're going to make it look like we're directly connected to the machine locally, and then it's part of this internal network. So in a couple minutes, I'll double check our connections to that, but this is going to be part of what we're going to use for testing a lot of these examples as well. Okay, so from this diagram, you can see what the wiring is going to look like for the Ethernet cables. There's also going to be a separate wiring diagram that is for the serial interfaces. So when we go through examples with the wide area network, or WAN protocols like frame relay, the point-to-point protocol, or PPP, and the HDLC protocols, we're going to be using these serial interfaces to simulate different WAN connections, like a T1 connection or a T3 connection that's similar to like a VPN, but a lot of times you use these to access the internet. So these two diagrams together, these are going to make up the physical diagram. Whereas I mentioned before, the physical network topology is going to tell you how the devices are physically cabled, so how they're actually plugged into each other. And what we want to know is what is the interface names or numbers. because these are going to denote different ports on the routers. Like in this case, if we look at the router physically, these ones are Cisco 2611XMs. Where this document here that says the hardware installation guide. Okay, we're going to look at these different documents throughout the week as we go through more details of the configurations. But this is part of the documentation of Cisco's website that says for this particular platform, what are the hardware details about it, like how many Ethernet interfaces does it have, how many fast Ethernet, how many WAN interface card slots or WIC slots that are used for connecting to like T1 connections or connecting to other devices through serial. In this case, we have a mixture of 2610XMs and 2611XMs, which essentially means that these routers either have 1 or 2 fast Ethernet interfaces. They have a network module slot, which is an NM, and they have 2 WAN interface card slots. From this physical diagram here then, router 3 has what's known as an NM4A/S, where this is a network module. Anything that starts with NM is a Cisco network module. And 4A/S means that this is an asynchronous connection and that there's 4 ports, where NM4A/S looks like this. This one here, understanding the 4-port and 8-port async sync modules. Okay, basically it looks like this, where these are the 4 serial interfaces. These use what are known as DB60 or 60-pin serial cables. And essentially on the other side of this, there's a 1-port version that these routers have installed. Where the 1-port version, this is called a WIC 1T here. So typically, these modules are what you would use to connect to the internet, like over a T1 connection. But we're simulating these by just connecting them back to back between the routers. So in the scheme of things, they're fairly slow speed interfaces, like they can only run usually about 2 megabits per second, which nowadays is pretty slow for a WAN connection. But the resulting configurations that we can do and the show commands, the verification commands, it's going to be the same as if we were to have like gigabit Ethernet to the internet versus just these connections. So as you're going through your preparation for CCNA and beyond, one thing that's nice about a lot of this is that you don't need the most cutting edge hardware in order to actually test this stuff out. Where if you were to go to eBay, you could pick up one of these 2600XM with the cards, the WIC 1T, and if you wanted the NM4A/S, for probably $100 or less a piece. Where when we first started doing this, Brian, how much was it for your first 2500 series router? $3,000 for 2500 series router. So they've definitely come down in price as the as the technology increases. So you couldn't really use these that much anymore for real production networks, but the key is that they're running the same software. So all the testing that we do is going to be relevant to any new hardware that you're actually working with in a real network. Now the Ethernet cabling, this is very straightforward. The routers already come with these built in. So depending on the model of the router, it's going to have a number of Ethernet interfaces, where the switches that we're connecting to are Catalyst 3550, 24-port versions. Where essentially this is similar to any other network switch that you've seen. Most of them visually look pretty much the same, where it's just a number of RJ45 ports that you're connecting to. But depending on the particular platform, depending on the particular version, sometimes you'll have options to do different types of connections. Like this one supports what's known as a GBIC interface, GBIC, which basically means you could connect to it through a fiber cable if you wanted to, or you could connect to it through copper cables. Just depends on, like if you have a server, say a web server that has a NIC card that's using fiber, then you would need to match that up with what's on the other side. So really the features are the same, because when we look at a fiber optic cable versus a copper cable, that's running it at what layer of the OSI model? It's running at layer 1. So layer 2 Ethernet doesn't really care, am I going over copper or am I going over fiber? It's only really the physical interface driver, the layer 1 function, that really cares about that. So from our point of view, we don't even really know from the configuration, are these copper cables or are these fiber cables? The end result is going to be the same from the network design point of view. It's going to be more of like a physical issue, like how long do I need to make the cable run? If I go beyond a certain length, then I would have to use fiber optics as opposed to using the cheaper copper cables. Okay, so the first thing that we're going to go through now on the command line is that ultimately we're going to be building a logical network topology that's going to turn out to look something like this, where we have this test PC that's going to be connected to one of the switches, and then we're going to be able to send network traffic to different portions of our network diagram or our network topology in order to test out different types of layer 2 protocols like Ethernet or PPP, frame relay, etc., and all sorts of layer 3 routing protocols like RIP or EIGRP or OSPF that's used to help the network decide how it wants to send the traffic, which direction, or basically how it wants to route the traffic. But in order to do this, the first thing we need to do is go through a basic initialization of the routers and the switches. I want to make sure that any other changes that have been made up to this point, that they're deleted and that we start from scratch. So when you log into the router, if it currently has a configuration, it's going to ask you to press return to get started, and it's going to drop you off at some prompt that looks something similar to this. Okay, here before this caret, or the, excuse me, not a caret, a greater than sign, this is the host name of the router. So like your Windows machine has a host name when you do your initial install, same thing with the router. This greater than sign means that we're at what's known as user mode in iOS. User mode basically means that you can have read-only access to the machine, that you can verify different things, like look at the layer 3 IP routing table. You could run basic commands like ping or telnet or traceroute, but you can't actually make any changes. So to allow us to make changes, the first thing we need to do is to authorize to a higher privilege level. What a privilege level is going to allow us to do is basically just to make changes to the device. So it's like your admin or your user login for any other operating system. If we want to get to admin mode and make changes, we have to type the command enable, and this is going to get us to privilege mode, where privilege mode is going to have this pound sign. Now you can also see this when you look at the show privilege. Show privilege is going to tell you what your current number is, where 15 is the greatest. So 15 is like root access to a Linux machine, or like your administrator login to Windows. So from here we can make any changes that we want to. Now the only change that I'm going to make at this point is essentially to erase the configuration and then reload it, so we're going to start from scratch. And there's a couple different ways that I can do this. You'll see that sometimes commands in iOS, they'll have two different, what we call the syntax, basically two ways to enter the command, but they end up in the same result. It's because basically the operating system has evolved over years. It's like 20 plus years old. So sometimes they'll leave in the legacy versions of the newer commands, and you can basically do either of them. So there's a couple ways to erase the config. One of them is to say write erase. What this does is erase what's known as the non-volatile RAM file system, or NVRAM, this is where the router stores its configuration files. So if we hit enter to confirm, that's going to delete the router's configuration. The other way to do this is if I were to say clear startup config. Clear start. So these two commands, write erase and clear start, they're essentially doing the same thing. It's just two different ways to enter the syntax. Now once you've done that, you can tell if the router actually did erase its config if you issue the show startup config. Basically this says show me the backup of your current configuration. Where normally if you power off the router and power it back on, or you reload it, the router's going to boot up and it's going to run this startup config, which is going to tell it things like what's my IP address on the interfaces, what are the different routing protocols that I'm running. So any changes that we make, that's stored in the startup config. So if the router loses power, it's not going to lose its config. But if it says the startup config is not present, it means that someone erased it, which is what I'm trying to do in this case. So once this is blank, I'm going to reload. And this is going to reboot the box. It says the system configuration has changed. Do I want to save my config? In this case, I want to say no, because I want it to be blank when it reloads. And I'm going to do this on all of the devices. So I either say write erase or clear startup config or clear start. You'll also see that in iOS, it doesn't require that you type in the full command in order to execute something, as long as it's a unique command, which is sometimes called a non-ambiguous, which essentially means that there's no other command that matches these keywords, WR space E. So the router knows that I'm really trying to say the command write erase, because there's no other command that matches WRE on its own. So you'll see that there's multiple combinations that you can enter in order to make changes like this. But if you at any time hit the question mark, the router's going to give you help on what the syntax is supposed to be. And this is known as the context-sensitive help, where no matter where you are in the router, if you hit a question mark, it's going to show you what commands you can type that are valid. Now in this case, notice that there's only one command that it says is valid here, where the command is erase. So if I were to hit tab, the router's automatically going to complete that for me, which is known as the tab completion feature. So anytime you type something and you're not sure if it's enough to make it a unique command, if you hit tab and nothing happens, it means that's not a valid command. So if I were to say something like the show command, okay, the show command is going to be used to check different states of the network. We're going to go through a lot of different show commands and see exactly what they mean. But if I were to say something like show and then the letter I, if I hit tab here, it's not going to complete this, because it means there's other commands that start with show and then I, where I could say show interfaces or show inventory or show IP. So I need more characters to complete this. If I were to say show IN and then hit tab, still that's not enough. But if I do a question mark now, it narrows down my choices. Where now ISIS and IUA or IPX, these choices are out because they don't start with IN. So you'll find that a lot of the times, even if you don't know the exact syntax of what you're trying to do in iOS, the tab completion and the context-sensitive help, a lot of times it's going to get you to point you in the right direction of what you're trying to do. Okay, so again, I'm going to say write erase, or in this case, I just had to say WRE. And you'll see the switches are a little bit faster with their processing. So now once all the configs are erased, I'm going to reload. And I'm going to reload on all of these. So every time it asks me this option, system configuration has been modified, do you want to save? It means since the last time that I saved my config, something has changed, and if I reload, I'm going to lose those changes. So if I were to say yes, it would basically undo what I did here. Normally, you don't want to erase the router's config and just start over, unless you're doing like the very initial implementation. So if this were a production router, normally you don't want to just delete its config and then reload it. Okay, but now we can see, depending on the platform, we're going to go through what's known as this system bootstrap, or basically the system post, the power on self-testing. So just like your Windows machine or any other computer goes through your initial boot up, it's going to go through some basic operations, like it tries to load its software. Here it's unarchiving it or decompressing the image. Then eventually, once it gets through this, so here we're going through some hardware checks on the switches. Once it goes through these basic hardware tests, it should eventually ask us, do we want to go through the initial configuration dialog, which is essentially like a setup wizard for the device. Okay, the switches are asking it here, do you want to enter the initial configuration dialog? Here I'm going to say yes. It says basic setup, management setup configures only enough connectivity for management of the system. Extended setup will ask you to configure each interface. Would you like to enter basics management setup? Sure. Enter the host name. I'll call this one SW2. The enable secret is a password used to protect access to the privilege exec in configuration modes. This password, after entered, becomes encrypted in the configuration. Basically, this is my admin password on the router. So the next time I come in and I try to get to that privilege level 15, which is to make changes on it, I would need to enter this, the enable secret. So I'll type whatever password in here. It's just something that I have to remember. So I'll say for simplicity is Cisco. Then it wants the enable password. The enable password is used when you do not specify an enable secret with some older software versions and some boot images. Now there's a difference between these two where the first of these, the enable secret, this is an encrypted version of the password. We'll see this when we look at the result of the configuration. But the enable password, this one is in clear text, or basically it's just whatever I type in here, that's what's going to show up in the configuration. So if someone actually sees the config, they're going to know what the router's password is, which most of the time is not a good idea. So typically you would use the enable secret and not the enable password. But for whatever reason, for leftover for older versions that don't support the enable secret, it still asks you to put both. So I'm going to put a different one here. I'll say Cisco 1. The virtual terminal password is used to protect access to the router over a network interface. Enter the virtual terminal password. The virtual terminal, or the VTY, this would be used if I was trying to telnet into the router. So if I want to remotely manage it over an IP network, and I telnet to it, it's going to ask me for this password. Configure SNMP network management. This is the Simple Network Management Protocol, or SNMP. What this allows you to do is to have a centralized management station that asks the network devices about what their current state is. Like, what's the temperature of your fan? Or how much utilization is there on your interface? Or how much free memory do you have? So it's used for general network management. There's tons and tons of stuff you can do with this. But for right now, this is outside of our scope of discussion, so I'm going to say no. Okay, it says this is the result of this. The current interface summary, it says any interface listed with OK value no does not have a valid configuration. This will come back to. Basically what it means is that the switch doesn't have an IP address. So I wouldn't be able to send any traffic to it, which is fine for now. I don't need to do that yet. But here, this output, this is the equivalent output of the command that is show IP interfaces brief. And this is going to be one of these really commonly used commands that basically checks the status of all the connected links on the router or on the switch and asks them what is your IP configuration. So this is the equivalent of like the IP command or ipconfig command in Windows or the ifconfig command in Linux or Mac OS. These commands here, I'm going to make a list of the commonly used ones, and then that's going to be part of the printouts I'll give out later. So you can write these down as I'm going through them, but you don't necessarily have to. It says enter interface name used to connect to the network management or to the management network of the above interface summary. Okay, here I'm going to say VLAN 1 is the interface. And it's sometimes hard to read this output because there's these other logging messages that are going on. Basically, these are telling me that the other routers are booting up because these interfaces are going up and down. But here it says for the VLAN 1 interface, do I want to configure IP on this? Now, anytime the devices talk about IP and it doesn't show a version, it always means IP version 4. If we're talking about IP version 6, it's always going to say IPv6. So IP on its own always means version 4. So yes, I want to configure an address. I'll say the address is going to be 192.168.0.7. And for right now, I'm going to number these 1 through 8, where the first one, router 1, I'll say is 192.168.0.1. Router 2 is going to be 192.168.0.2, etc. down the line. So 4, 192.168.0.4. Okay, so all the way down the line where then switch 1 is 192.168.0.7, 0.8, switch 2, no, that's not right. That will be, there's 5 routers here, not 6. I'll say this is 6, 7, and then 8. So did I make that change already? Let's see. Switch 2 is going to be .7. Okay, so that's good. The subnet mask for the interface. Now, the setup program here automatically chose 255.255.255.0 for me. Does anybody know why that it said here my subnet mask automatically was this value? Because these addresses here, these are part of the Class C networks, which means that by default they would normally have a /24 subnet mask or a 255.255.255.0. Okay, we'll talk about this in more detail when we go over the specifics of IP. But originally IP addresses were split into 5 different classes where they're A, B, C, D, and E. Where the A addresses go from 0 to, does anybody know? 0 to 127. The B's go from 128 to 191. The C's go from 192 to 223. The D's go from 224 to to 247, I want to say. I'm going to have to double check that. Then D, or no, I'm sorry, 239. 239. E's go from 240 to 255. Okay, these ones aren't used. For whatever reason, they're not allocated. They were originally part of like a testing allocation, and they never used them. These ones here, D, these are addresses that are called multicast. I'm not sure if multicast is in the scope of CCNA, but we will talk about that a little bit when we get to IP. Basically, these are the only three ranges that we would use. So if you look at an address on the internet, it's going to be somewhere in this range. It's going to be somewhere from 0 to 223. Now, not all of these are actually valid. There's cases where there's addresses that are assigned for other reasons that you can't actually use. But these classes A, B, and C, these are going to be my normal ranges for IP addressing. The A addresses were assigned a default subnet mask of 255.0.0.0, or basically /8 in binary. The C's were assigned 255.255.0.0, or /16. The C's were assigned 255.255.255.0, or /24. So since my address here that I was trying to automatically, or that I was specifying, it fell into this class C range. So the switch is assuming I want to use a /24, which is fine for now. As long as all of my devices agree on the subnet mask, this is really all that I care about up to this point.
So on our routers, we're doing loopback 0?
You can. Does it ask you for that?
No, I was just asking if that's what you wanted to use as management.
I don't know if the setup dialog will allow you to do that. What I did, I said VLAN 1. You can try doing the loopback and see if it'll allow you to do that. We're going to talk about loopbacks and what they're used for, though. Okay, would you like to enable as a cluster command switch? Okay, this feature I don't need on this platform. It's actually not supported here. I'm not sure why it's asking me. But basically what this is used for is if you have multiple physical switches, like let's say I have 4 switches that I want to configure, you can configure them in a cluster, which means that you have one device that controls the configuration of all of them. So I don't have to configure switch 1 separately than switch 2, then switch 3 and switch 4. So it's one management interface that talks to all of them. But in this case, I don't need to do that. These are going to be separate switches. Okay, it says here, this was the result of my initial config dialog. So if I were to apply this and then look at either the show running config or the write terminal, we'll look at both cases, this is the end result of all those questions that it asked me. So basically it's giving it a name, the host name, it's giving it the admin password, the enable secret, and the enable password. Whereas you can kind of see here, the enable secret, you don't know what this value is because it's an encrypted value. This one here, the enable password, this is in clear text, which means you can just read what it is. Line VTY015, this means if you were to telnet into the router, it's going to ask you to put the password Cisco in. Symbol network management protocol is not configured. Right now the switch is not routing IP, which is fine. We'll come back and talk about when it does need to route IP. I then have this interface VLAN 1, which has the address 192.168.0.7/24, and this is in the no shutdown state, which basically means it's not disabled. Where if you were to say shutdown on an interface, that turns it off. So if you need to temporarily disable a link for some reason, you just go to it and say shutdown. It's the same result as unplugging the cable. But in this case, it's shutdown in software as opposed to shutdown in hardware. Okay, the rest of the switching interfaces, these have a blank config. So we don't need to worry about any of these yet. So there's 24 ports of fast Ethernet, and then there's 2 ports of gigabit Ethernet. So now it says, what do I want to do? Do I want to save this config? Do I want to go to the command prompt without saving the config? Do I want to return back to the setup without saving the config, so start over, or save this configuration and exit? So let's do the second option, save and exit. Okay, so now if I were to look at the show running config, this is going to show me the result of that change, which again was here like I pasted in Notepad. I would be able to see this change if I was at the administrative prompt. Okay, right now I'm not at the administrator prompt, I'm at the user mode. So to issue this command, I would have to be in enable mode or privilege mode. Okay, privilege mode is the when you can make changes to the router. So if I were to say enable, it's now going to ask me for this password that I configured as the enable secret. So if you didn't already know this, then you're not going to be able to find it out because this is an encrypted value. But I know that I typed the password Cisco before, which is fine. So now it drops me off here at privilege 15. If I show privilege, it says I'm at level 15, so now I can make changes. If I were to say show running config, SHOW run, or running-config, this is going to show me what's the current state of the device. Where some of this you'll see is what the changes that I made through the initial configuration. Some of these will be defaults. Like it says that if I generate a debug message or I generate a log message, I'm going to put a timestamp on it that tells me how long the router has been booted. So you saw that before when some of those messages were coming up. That's what this is showing here. This is the current uptime of the box. So it was 4 minutes and 28 seconds since it reloaded before it generated this logging message. Most of the time in a real network, you wouldn't want to do this. You would want to set the timestamps to be the local time. So then if something changes, you can correlate it with, well, that happened at noon on Friday, as opposed to it happened 582 hours since the last time the router reloaded. But by default, it does logging based on the uptime. Service password encryption, we'll talk about this later when we get to security. But here we see the host name, we see the enable passwords. Since this is a switch, it's running spanning tree. It says the mode of spanning tree is per VLAN spanning tree, or PVST. And we'll talk about what that means when we compare it to the other spanning tree versions, when we get to LAN switching in more detail. Okay, all of these interfaces, they're not running IP yet, at least. They don't have IP addresses. I do have a VLAN interface, VLAN 1, that has an address, 192.168.0.7. And then this is the telnet access. Okay, so let's go through the rest of the devices. I want to see if they actually reloaded yet. Okay, all of them should be asking me now, do I want to enter the initial configuration dialog? So for these ones, I'm going to say no, I don't want to. Now, since I said no, the end result is going to be that the router's prompt is eventually going to come up. Its default host name is router. The default switch's host name is switch. And essentially, they have no configuration. This is a blank configuration on them. So they don't have any of the passwords set. They don't have any of the IP addressing set. It's going to be 100% just basically like a blank install of iOS. From these, if I were to look at my show privilege, it says I'm at privilege level 1, which is my user mode. So again, I can verify basic stuff, but I can't change anything. So if I wanted to change anything, I have to say what first? EN for enable. Now, since the router didn't have a password set, it just automatically lets me in, because right now everything is blank. So if I look at the show running config, I could also just say sh run. I could also say write terminal, where write terminal is the original version of this command. So it could get a little bit confusing because they have these overlapping commands. But write terminal, this is equal to show run. Write erase, this is equal to erase start. Where if you're mistyping one of them, you want to show the config and you accidentally delete it instead. This is probably why they changed it. Because show run and erase start, they're completely unrelated. Write terminal and write erase, you could theoretically accidentally type one versus the other. But either of them are still going to work. Write terminal is still going to show me the config, RWT. If I wanted to save my config, you can just say write. This is equal to copy running dash config to startup dash config. This one is what saves the configuration. It makes a backup of it. You'll see that a lot of people, instead of issuing this command, will just do this instead, WR. This is a shortcut for the write command. So it's a quick way to save the config. In the actual exam, though, for CCNA and CCNP and like the CCENT exams, you want to know what the full syntax of all the commands is. So when you get to the simulations, it may accept the write command, it may not. Even though it technically does the same thing in a real router, 99% of the CCNA books say it's copy running dash config startup config. But as far as I know, the simulations do allow you to run context-sensitive help. So you could say copy and then do a question mark. I want to copy my running config. Where do I want to copy it to? I want to copy it to startup config. Okay, this would also be the same as saying copy run start. Because there's nothing else that starts with RUN, so it automatically is going to match running dash config, and the same with startup config.